Looking at this first step, so again, notice I'm evolving these steps as we go through these different examples. I've combined this, the way that I explain it will combine finding the LCD and writing as a single fraction. Okay, well, there's something that's kind of implied within finding the LCD. In order to find the LCD, you need to know what the factors of the denominator are, so that has to be kind of a part of this first step. You need to factor everything completely. So when we look at the denominators here, we have the difference of squares, so that can factor into the sum and difference of those terms being squared, so x plus 4 and x minus 4. And then this second fraction's denominator can also be factored. It has binomial factors. The last terms are the two factors of 16 whose sum is 8. Well, again, you can either think of this as a perfect square trinomial, or those two numbers are plus 4 and plus 4. I don't care how you think of it. It may be easier to visualize sometimes if you're thinking in terms of the exponential form. I'm going to go ahead and just leave it right here. Okay, so when I write this as a single fraction, I'm going to take my LCD. Well, when I look at my LCD, I need to have every individual or distinct factor. Okay, no repeated factors from the denominators. So in my first fraction, I need an x plus 4 and I need an x minus 4. Okay, so those are two of my LCD factors. In my second fraction, I need an x plus 4 and an x plus 4. Well, that means I need two x plus 4s. How many x plus 4s do I already have? One, so how many more do I need? Just one more. So I have a total of 2, but I don't need 3 down there, because the fewest, the least number of times x plus 4 has to be a factor is 2. Okay, so here's my LCD factor. As part of writing this as a single fraction, involves writing out the numerator. Okay, so to find the numerator, you're going to multiply each factor of the numerator by any LCD factor that's missing from its denominator. Okay, so what that means is I'm going to go through and I start with my first factor of the numerator. It's a 4. I'm going to multiply that 4 by any LCD factor that's missing from its denominator. Well, it has an x plus 4 and an x minus 4, so it's missing the other x plus 4. I'm then going to move to my next fraction's numerator, so plus 3. And I'm going to multiply that by any LCD factor missing from its denominator. Well, it has an x plus 4 and an x plus 4, so it's missing the x minus 4. This can now lead me to my next step, which is to combine the terms in the numerator. So when I combine my terms here, I'm going to distribute. I get a 4x plus 16. Distribute my 3 plus a 3x minus 12. Now notice here, I don't need to keep rewriting my denominator. My denominator is not going to change. Once I find my LCD, that's going to be the denominator. So x plus 4, x minus 4, x plus 4. So in this step, all I need to do is work with the numerator. So I can combine it. 4x and 3x is 7x. 16 minus 12 is plus 4. So I get 7x plus 4. Okay. My final step here is to simplify my resulting expression. And again, embedded within this command is the factor completely, cancel common factors, identify domain restrictions. In this case, there are no other common factors to remove. There's no factors to cancel. So I can just write my answer. Whenever you write your answer, if you have repeated factors, what I would like you to do is write repeated factors in exponential form. So x plus 4 times x plus 4, I want you to express it as x plus 4 squared. I don't care which order you write these factors in the denominator, I just want it to be written as that exponential. And then there's no canceled factors from the denominator, so I don't need to account for any domain restrictions from here.